So if we dive a little bit more into the shape of our distribution, we'll see that there are three different important aspects we want to describe. And describing shape is something I have definitely asked for on exams before. So you want to make sure that you have these three things down. The way I will help is I will say make sure you include all three aspects. That does still require that you know I'm talking about mode, symmetry, and unusual features. So when we talk about modes, that's how many bumps our data has. So most of the data we've seen so far has been unimodal, right? There's just one most common sort of outcome area, one most typical area. And so that's even true with our data we saw before. I will have some students try to tell me that this thing is bimodal because of this little gap here, but I want you to think of it a little more holistically. Like if you kind of just went over the edge of this, we definitely see this as unimodal as well. Bimodal would have two different outcomes. You see this a lot when you combine groups. As long as the groups have different enough centers, you'll start seeing a bimodal distribution. And then multimodal, something like chess ratings, but this means that there's more than one mode. This one in particular seems to have what we call a uniform distribution. Uniform means they're all equally likely to happen. All right, so that's our modes. Most common thing we're going to see in this class and in life is unimodal data, where there's one most common outcome. Like I said, bimodal is usually two groups sort of combined, and multimodal, the most common way you'll see that is in a uniform distribution where everything is equally likely. Symmetry is all about how our data is spread out about from that center that we talked about. So symmetric, something like this is fairly symmetric. It doesn't need to be perfect, right? But we have something that is fairly symmetric versus something skewed where we have our center and then we have this long tail off to the side. Now, if you tell me something's skewed, you need to tell me the direction. So if the upper tail is longer, then we have a positive or right skew. So this is a right skewed distribution. This is the opposite of how a lot of students think of it, because they think of the majority of the data sort of being the part that matters, but we talk about the skew based on where the tail is, so it's all about the tail. So in this case, our tail is off to the right. And then our last piece is the unusual features. Two things you might want to look for, and those are gaps and outliers. So in this social media question, right, we can see there's a gap. There's no students who use social media between 11 and 12 hours. And then we have an outlier, some student that manages to be on social media 12 plus hours a day. And when you tell me there's an outlier, you also need to tell me where it is. So that's another mistake students make, because they start describing, they say, okay, there's an outlier, but you have to assume that I don't know how to read a graph. And that maybe I don't even have the graph in front of me. So write this as if I cannot see what's going on. So that's the unusual features that we might want to talk about. And then there's one note here. For things that are unimodal, symmetric, and bell-shaped, we'll call that approximately normal. So this particular graph would fit our approximately normal. So we got some shorthand to talk about things, uniform and approximately normal being two pieces of shorthand for us. So now that we have a slightly better statistical vocabulary, we're going to do one exercise doing this description for us, and that is to look back at those wind speeds from Hawaii. So now that we know everything that there is to describe about a distribution, we're going to work through it. So before you try this on your own, by pausing, I'm going to remind us that the distribution itself has three aspects: center, spread, and then the shape. And then remember, shape itself has three aspects, which is modes, symmetry, and unusual observations. So now that you've got everything defined, take a moment, pause the video, see how you do at describing the distribution for this histogram. So if I was to describe the center here, the easiest way to describe center is to just talk about the mode. So the mode is the tallest bar. The most common outcome is that wind speeds are between 50 and, remember, 55 miles per hour. You do not have to worry too much about the correct interval notation here, as long as you made it clear that you understand that is the tallest bar, and it's from 50 to 55. The spread, again, the best we can do right now is we can talk about the range. And so our range for our data, the lowest wind speed is somewhere here, which again, don't write 0 to 10. This is from 0 to 5. And our highest wind speed is at 65 to 70. We cannot just say 0 to 70 because we do not know what the actual speeds were. So this is the best we can do. And then we break down our modes. This is another one. A lot of students want to say bimodal. If you said bimodal for this one on a test, I would probably give you full credit because I can at least see where you're thinking and I could see where you might have that decision. But this to me is definitely unimodal. If I chopped this off and put it there, we'd be in unimodal land for sure. So one value should not make a difference in terms of unimodal versus bimodal. Symmetric, well, we can see this thing is not symmetric. There's a lot more going on over here. If we drew our little shoop, we can see our tail is on the left-hand side. So remember, don't just tell me skewed. You have to tell me skewed to the left or negatively skewed. And then our last thing, unusual observations. So again, we have both of the things we talked about in the previous page. There is a gap at 5 to 15 and an outlier at 0 to 5. So we're not going to assess whether or not that's something going on, but that outlier is just, we want to tell somebody about it in case for some reason that like the machine was malfunctioning on that day, whatever they used to measure wind speed. They could throw that value out. Or they could confirm it was just an unusually calm day. So the last exercise here, which again, I'm going to recommend that you pause the video for. I'll actually split it into another video because it's getting long. But I want you to guess at what this would look like. So hold on. I'm going to come back in a different video so that we don't have a super long one.